Good morning, everyone. Today we're going to continue our discussion on the very powerful method Arima for modeling time series. So let's have a quick review. These are the packages that we're going to use, that we have been using for the past days. And what we did last time was to download Apple dataset from using quant mode's get symbols. And then after that, we extracted the closing price. And then from the closing price, we got the returns. Okay. So let me go to that part. Okay. Here. So how do you get the log returns? We learned this already before. You get the log, okay, log and then difference, not the other way around. We don't use log diff because if it will get the difference first, and which will normally or 100% surely generate negative values, and then you proceed to get the log, which will yield not a numbers, because you cannot get the log of a negative number. Okay, so we learned this. When we run this class, we will generate the first row to be an NA, because your the earliest data will not have a previous data, so you cannot get the difference of that. So in order to delete that, because R will not work if there are missing values, we use this NA.omit. Okay, and so we have this, we should have this data, this one class. So no NA, the first row, with 2,515 observations. only one column. Okay, any questions about that class? Could you kindly chat, please, if you're okay with that so far? Okay, thank you. Thank you, James. Okay, good. Okay. Thank you for your feedback. All right, let's move. Let's proceed, class. And we plotted these Apple log returns, and we said that it's important for us to determine whether the time series is stationary or not. You cannot use Arima model if the time series is not stationary. Okay, so here, what happened here is that there is no trend and no apparent, and the variance appears to be constant. But we don't just use a visualization, we also use a statistical test. And two of the most popular ones are the ADF test and the KPSS test. So we ran this last time. This is from the T-series package, augmented Dickey-Fuller, that test. So we're testing the log returns, Apple log returns, and this generates this result. The null hypothesis is that the time series, the Apple log returns, is not stationary. And the alternative is that it is stationary. With a p-value equal to 0.01, the result is that the inference is that we reject the null hypothesis that the time series is not stationary. Okay, there's strong statistical reason to believe that the time series is indeed stationary. And we also used the KPSS test last time. KPSS, that test, the difference is that the null hypothesis here is the reverse. Okay, so the null hypothesis here is that the time series is stationary with a p-value equal to 0.1. Our conclusion is that we fail to reject the null hypothesis that the time series is stationary. Indeed, the time series is stationary. So after that class, we said that the next thing to do is to plot, okay? Plot the ACF and the PACF. The function is straightforward, ACF and PACF. So what we did was to plot this. You can actually plot this individually. If I run the first one, Control Enter, This will give us the ACF here. And if I run the second one, it will give us the PACF there. Okay, so what's the use of this? I'll run both. Partition, or plot. Okay, what's the purpose of both? You do compute for the ACF and the PACF because this is where we identify whether your time series follows an MA process or an AR process or an ARMA process. Okay, so this is where we make the choice, class. So the question is, how do we determine if this is an AR process or an MA process? So what you do is you take a look at the ACF. Okay, in this case, notice that the first correlation here is at 0, and it's equal to 1. Of course, we said last time that correlation at log 0 is equal to 1 because you're just getting the correlation of the time series with itself. So the correlation of the time series with itself is equal to 100%. It's equal to 1. Okay, so that's not what we need. What we need is this one, the correlation at logs other than 1. If these are significant, and how do we know they're significant? The logs should go beyond the Bartlett bands, this blue one. Okay, so for example, at log 2, if it is this one, so you notice that it measures a strong correlation between your original and your log 1. So in this case, class, this is your correlation at log 1. This is significant, highly significant because of the high value here. And you notice that this is followed by non-significant logs, except for this one, but they're logs from 7, 8, 9, I think. And usually if they're far, class, if they're far, then usually they really don't become part of the solution. Imagine you have a log here at 36, for example, and the correlation is this one. There must be a reason why this is significant. But usually you don't create an Arima model where the logs, your order is very, very high. Okay. All right. So that would cause some problems with your model. So for the ACF, if you have significant spikes, these are spikes, class, and they're significant, and then you have non-significant spikes already, then that could mean that this is an MA process. Okay, so you have to know that if your ACF looks like this, let me redo that. So this is log 1, log 2, log 3, and this is your Bartlett band, that blue one. So any spike beyond these blue lines are significant. So let's say this is this side, and let's say this is 0.8. So the correlation is around 0.8. So that's quite high. Okay. So this is ACF class, ACF. So you have significant spike at log 1, and the rest are just insignificant. Okay. Maybe here, there, negative here, negative correlation here, but all of them are not significant. Right? And then your PACF looks like this. Your PACF, on the other hand, looks like this. It looks like more of a geometrical decay, an exponential decay like this. So it's going down very, very fast. Okay, for this one, it's not going down very fast. There are significant spikes. So if your ACF looks like this and your PACF looks like this, then most certainly or most probably it's an MA process, moving average process. So that's how you use, class, the plots of the ACF and the PACF. It's used to determine what's the possible model for this. Now, if it was reversed, this was the PACF, and then this was the ACF, then most probably it will be an AR process. Okay, so you use the PACF in order to determine if it's an AR process. You use the ACF to determine if it's an MA process. If both of them have significant lags, okay, take a look at this class. Okay, yung PACF dito, it looks like parang small decay siya, no? Although it's in opposite direction, but it's similar to like this class. Going down fast. Okay. So as I said, class, if your ACF looks like this and your PACF looks like that also, parang pareho lang na may mga significant spikes, and then wala na, cut off na, okay, no more significant spikes in the other lags, then that would indicate that this is an ARMA process. ARMA. Significant spike in the PACF, significant spike in the ACF, then that could mean it's an ARMA process. Okay. If it's slow decay class, how does a slow decay look like? Maybe perhaps let's why don't we take a look at certain hold the line class. Okay, let's see. I think I provided you this sample ACF and ACF plots. Do you have that class in your notes? Do you have it? Hello, class. Okay, anyway. Okay, let's try to see. I was looking for examples of ACF and PACF. I think this is a good source. No, this is not. Okay. Anyway, class, you can find this one, class. Okay, this one is well, it's hard to say if it's a slow decay. It's geometric. Okay, yeah, this is geometric. Okay, a geometric decay, but let's go here. Okay, if you take a look at this one, class. Okay, this is log 0, right? So this is 1. Okay, but we pay attention to this one. This correlation here, which is log 1, it's a correlation between your original time series and log 1, is around 0.4 or greater than 0.4. And it's statistically significant. So this is what we call a significant spike. And then no more here. Okay, no more here. So significant spike at the ACF would indicate that this is an AR process. And for the MA process, I mean. For the PACF, you notice that this is slow. This is a geometric decay. Okay, if you can put this on top, make it positive, so it will look like as if you're, okay, can I write here? No, I can't. Okay, so this looks like a geometric decay. A geometric decay looks like this, okay, quickly going down, as compared to a slow decay. Slow decay is where you plot it, it takes a very long time for your correlation to move, to go down. So that's a slow decay. This, on the other hand, is geometric or exponential decay. All right. So if the if the plot was reversed, class, then let's say this is your PACF, you have a significant spike here, then that indicates that this is an AR process. So this summarizes, class, the behavior of the ACF and the PACF. Okay. So for example, if the ACF is geometric, okay, when I say geometric, your correlation moves this way, just like an exponential diagram. And the PACF, okay, in the PACF, there are P significant lags, then that indicates that it's an AR process. If it's MA process, you have significant lag at the ACF, and you have a geometric decay at the PACF. Then if it's both geometric, then that indicates that it's an ARMA process. Okay, it's an ARMA process. All right, so that's just an example. You can look for more examples. I suggest you look for, there are many other examples in the internet. Okay, so going back to our lesson here. Okay, here it seems to indicate that there's a significant spike here, but it's quite small. Okay, and here it looks like more of a geometric decay. Okay, so sometimes it's really difficult to ascertain this. So that's why it's more of a trial and error. You first see if it's an MA1 or an AR1, and then you keep on trying until you get the lowest AIC. So how do you determine which is the best model? You compare it based on the Akaike information criterion. So this one you have to compute AIC. Akaike information criterion, which is a measure of information loss. Okay, good thing we don't have to manually compute this. There's a formula for this. We're not going to learn how to compute for that. However, we're going to learn something this afternoon, which was asked of me. I'd like to clarify what we discussed before. Okay, so you can actually get the values of your ACF and your PACF. I want you to write this code, class. So here, I'm creating this object ACF result, which is just your ACF. Okay, we ran this a while ago, ACF of your data, and then we just include here plot is equal to false, so that it will not plot, it will not create a plot of your ACF. If you don't include this class, then it will automatically, for example, I comment that out, and then if I run this, then it will automatically create a plot of your autocorrelation function there. Okay, Control Z, there. If I run this instead, okay, Control Enter, then I'll be creating an object called ACF result. Diba? Magkaka-ACF result ako dito. Okay, and this one is a list, and it contains kasama yung values ng ACF natin up to the 35th lag. Okay? Bali 36 kasama yung lag 0. Okay, that's the default 36 lags. So kinompute niyan from lag 1, lag 2, lag 3 hanggang lag 6. So because it's part of the it's inside the object, we can get this ACF. Okay, so this is how you print it. For example, here class, ACF result $. Remember, $ACF. And maybe let's print the first 10 autocorrelations. So this one, 1 to 10, it gives you the lags 1 up to 10. All right, so I've run this. I'm now going to run this. Control Enter. So you notice the first autocorrelation is lag 0, which is lag 0, as we said, will have a correlation of 1. And then this is autocorrelation lag 1, lag 2, lag 3, lag 4, lag 5, lag 6, lag 7, lag 8, lag 9. Okay, and if you see class, let's just compare that with a plot here. Here, I'm going to plot this one. You notice that the correlation, okay, this is lag 1, 2, 3, 4, 5, 6. This is lag 7. Lag 7's correlation seems to be higher than lag 1, right? Because of the higher, the bigger height here. 7, 8, 9. These correlations seem to have a higher correlation here, class, compared to this one. Okay, and the rest are not significant. Okay, this is what we mean by P significant lag. This one also, but as I said, when it's significant at a far lag, usually it does not enter the model. Okay, kasi that can create problems kung masyado malayo na yung lag. Okay, so verifying that lag 7, 8, 9 ang pinakamalaki, di ba? When we look at this class, lag 7, 8, 9. Okay, tingnan nyo class. They exhibit the higher correlation as compared to the others. Okay? Mas mataas pa kaysa kay lag 1. 0.06 lang si lag 1. And this is positive, so above the, ano siya, di ba? Above the line. Ito negative, so below siya. And positive again. Okay? So you can see that this verifies yung ACF natin. All right, any questions about that? Let me pause for a while and seek your comment, feedback, if it's okay so far. Okay, thank you. Lorraine, thank you. Richard, thank you. Okay, good. Okay. Thank you. You can do the same. Yes, you can do the same also for your PACF. Copy nyo to, class. Copy nyo to. Tapos palitan nyo lang to ng PACF. Gawin nyo tong PACF result, PACF result, no? Okay, let's see, class. This one. So I'm creating this object, PACF result, PACF ng Apple log returns. If I run this, again, plot is equal to false. If I run this, it will now generate my PACF, okay? PACF object here. It's also a list. View this. And then, andito din yung object, no? Yung ACF. No? So, hindi PACF yung pangalan niya, but just PACF. So, that's why yung next code class, okay, the next code is, ganun din, okay, PACF underscore result, and then dollar ACF din. Okay, kasi yun lang makukuha mo, di ba? If I, for example, if I press dollar here, yan ang mga available, no? ACF type, wala namang available na PACF. But that ACF pertains to PACF. Okay? And then we run this. So ito yung first 10 na partial autocorrelation. And we know that the first one is the same as your ACF1. And say 65942. Parehong-pareho siya. Okay? Pero iba na, of course, yung PA's partial autocorrelation at lag 2, lag 3, lag 4, lag 5. Okay. And also you can see here, ano ba yung malaki din dito? Ayan, no? Anong lag to? Lag 1, 2, 3, 4, 5, 6, 7, 8, 9. Sila din malalaki. No? 0.81, negative ulit, 0.67, 0.85. So if you take a look at the partial autocorrelation, that's this one. Okay, ganun din, no? So significant sa lag 1, 2, 3, 4, 5, 6, 7 significant din. 7, 8, 9. Doon sa mga lags na yan, significant. No? Significant at lag 1. So ang question, is this a geometric decay ba to? Exponential decay? Or is this a significant lag dito? Tapos wala na sa iba. Although meron dito ano sa lag 7 and 8. If we can consider this as just, kaya nga mahirap class, no? Hindi siya exact science. Kasi may makikita tayong ibang ano eh. No? Okay. Again, class, sorry. Okay, so if we can assume that the significant spike is here and then these are just random shocks, then you have here a significant spike at lag 1, okay, then this could indicate that this is an AR process. Okay, so as I said, it's quite challenging. It's difficult to really pinpoint, what is this really? Is it an AR process or an MA process? So this really takes an iterative process. Okay. So somebody asked me, class, about the computation of the PACF. So let me just illustrate that now quickly. Okay. So first, we'd like to, okay, please install, I'm sorry, install these packages. We need the Open XLS package, and please load it. I'll give you a few seconds. We need this because we're going to work, uh, we're going to compute the ACF and the PACF this time. Let's use Excel because it's easier to work with that in Excel. Okay, so please tell me if you have completed that. Because I'm going to teach you how to write write in Excel a file that you have in your art project. So if you're done, class, with it, kindly please chat yes, so that I may proceed forward. Okay, thank you. All right. So make sure that your OpenXLX is already loaded. Okay, so we go here. This is how you write, okay, write an Excel file. Okay, so take a look at this, class. Okay. So this is coming from the OpenXLS package, and then we're using write.xlx. Let me put this in the second line. Okay, so here I'm writing as.data.frame. Okay, because we cannot you can write an XTS object in Excel. So as.data.frame, what object? This object. I want this to be written in Excel, and what name would you want to give it? I'm just going to give it the same name, Apple log returns, or you can name it any way you want. Data XLXX, okay, etc. Okay, when you do this, class, write.xlsx, it will generate an Excel file, and it will be saved in your R project. So can you do it, please? Can you run this? I already ran it, class. And you should generate this object, class. Apple log XLSX. Kindly chat, please, yes, if you were able to write that object and create that object, which will be saved in your working directory or in your R project. That's why it's really very convenient to use an R project. Okay, waiting for your feedback, class. If you were able to create it, you should have this in your files. Feedback, please, class. Okay, let's give the others a few more seconds. Okay, only 4 out of 31. So let's give your classmates a few more. Okay. Okay. A few more seconds and then, okay, good. I hope everybody's able to follow along, follow the instructions. Okay, last 10 seconds. All right. So you should have this class, and when you open your folder, okay, I'm going here to this is my folder. I can click this to open this file. Okay, so please click the Excel file. You cannot click it from the R because it will open as a window in R. So you'll have to click this in your file, in your directory itself, in your folder itself, so that you open a file, okay, and this is what you get. You have here Apple log returns. I just replaced it, okay? All right, you should have this class. There should be how many observations? 2515 observations. And these are all your returns. And there's a portion here that has 0 returns. Okay, let me just okay, let me just copy the format, okay, or increase the decimal place. It's practically 0, okay? All right, are you with me, class? Do you have the Excel file? After running the code, questioning, yeah, the Excel file should be inside your, well, it should be saved in your files, but when you open your folder, it should be there, just like here, this one. This is how I named my Excel file, and this is how it appears. Okay, Kevin, did that answer your question? Okay, good. All right. So have you opened the file, class? I hope you have opened the file. Okay, so here's the file. You may want to change this by y sub t. Okay, just to shorten the name. Okay, so this is our time series, and this is what this is what we're modeling, right? So we need to get log 1, log 2, log 3. So let's do it. Y sub t minus 1. This is our log 1. This is our log 2, y sub t minus 2. And this is y sub t minus 3. You can go on and on, but we'll just get up to 3 logs. Okay, how do we get y sub t minus 1, the log 1? Okay, that we can just copy this. So I go to the first cell, Control Shift down arrow. Okay, I hope you can make use of the keyboard shortcuts, because if you keep on scrolling, it will take you time. So once again, in Mac, I think it's Command Shift down. So in Windows, Control Shift down arrow there, and then Control backspace to go back to the original place, and then Control C. Let's copy this, and then I'm going to put it here. Control V. So I copied it here, class. One step down, and then if I go down, go back here, control down arrow, okay? You notice now that there's an extra one here. I'll remove this, okay? So this is our latest value. This is the log 1. Notice that indeed it's the log 1, right? Okay, so it's just like copying from 2551 up to the end and then pasting it here. Okay, but I think what I did was a lot easier. So control up arrow. Okay, so notice that of course we will have one unmatched. Okay, so same thing for y sub t minus 2. Okay, this one we can use this Control Shift down arrow, Control backspace, and then copy Control C, and then we paste it here, Control V. Okay, Control down. Okay, we can see now that, let's check, 1335217, 1330653. Okay, so this one we remove. Okay, this is supposed to be this one, This is this one. This is okay. This one is this one, 2 lags. Okay. All right. Then also for lag 3, very easy also. Okay, you can just copy this lag 2, Control Shift down arrow, Control backspace, copy Control C, and then go here, Control V. Okay. And then go here, Control down arrow. And I'm going to remove this one. So we're now matched with the latest data here. Okay. And each of these will have lock. This one will lock 1, this one will lock 2, this one will lock 3. Okay, because of the lags. Okay. All right, so let's now compute for the ACF. Let's put your ACF here. ACF, autocorrelation function. And then let's get lag, let's see lag 0, lag 1, lag 2, and then lag 3. Okay, let's compute for these lags. We know that lag 0 is equal to 1 because you're just getting the correlation of the time series with itself. So we can make use of the correl function, and then your array 1 is, okay, this one, Control Shift down arrow to go down. Okay, you don't, to avoid scrolling because that will take long. Control backspace. So we're going back to the active cell, comma. Okay, array 1 and array 2, what are we correlating it with? The same thing. That's lag 0. Control Shift down arrow, Control backspace. There. So it's exactly the same series class. A2 to 2516, and then A2 to 2516. So of course, Control Enter, you get 1 here. Of course, the correlation is 1 because it's just the same time series. All right. So any questions with this one, class? Okay, better. Are you able to follow for lag 0, class? Kindly chat yes, please, if you were able to follow. Okay, thank you. Okay, good. All right. I hope the others are able to follow, class. One more time. Okay, sige. All right. So let me repeat the process. Thank you for the question, James. So let me. Okay. For lag 0, you'd like to get the correlation of the time series with itself because there's no lag. Okay. So we're going to use, to get the correlation in Excel, we use correl. So returns the correlation coefficient between 2 data sets. So lag 0, which means you get your time series, this one, and don't scroll down because that will be too fast, too long. Control Shift down arrow. There, it will highlight everything. Okay, and then back to the active cell, Control backspace, right? And then comma. Okay, and then same thing. Highlight this, Control Shift down arrow, Control back. Okay, we're now back to the active cell. Shift parenthesis. Okay, to close the parenthesis, and then Control Enter. The answer is still on that active cell. So we have 1 class. Okay, James, did you get that?
Yes, po, sir. Thank you.
Okay, sure, sure. Do you sure?
Yes, po, sir. I'm sure.
Okay. All right. So now let's get the correlation sa lag 1. Sa lag 1 naman, class, we're getting the correlation of the time series with the lag 1. Okay, this one, y sub t minus 1. However, the data point should be the same. So we should be getting this correlation up to the data below. You cannot include this because if you include this and then just get this, there will be an error because for correlation, the data points, the number of observations should be the same. So let's do this, correl. Okay, correl, and then we're getting the correlation between these two. Okay, so this one first, Control Shift down arrow, there, Control backspace to go back, comma. Okay, so this one, Control Shift down arrow, Control backspace. There you go. And then Shift close colon, close parenthesis. You can see that they have the same size, A3256, B32516. Okay, and then Control Enter. Okay, so that's the correlation between your log 1 and your log 2. And you repeat the process for log 2, and log 3. So I'll go over this quickly. Correl, okay, for log 2, it will be this series and this series. So I'll start with this one. Okay, Control Shift down arrow, Control backspace, comma. The partner is this one. Control Shift down arrow, Control backspace, Control close parenthesis. Shift close parenthesis, and then Control Enter. So that's now your correlation for log 2. And then your correlation for log 3 is equal to, same thing, correl. Okay, correl. For log 3, it should be this one. This one and this one, right? Control Shift down arrow, Control backspace, comma, move here, Control Shift back down arrow, Control backspace, Shift parenthesis, Control Enter. There. Okay, let me pause for a while, and could you please tell me if these are practically the same values as our ACF in R? There will be some deviations because of rounding off. May I have your confirmation, class, if these values, log 1, log 2, log 3, are practically the same as your values in ACF in R? Kindly confirm, please. Similar, thank you. Please send your message to everyone. Okay, thank you, Sabrine. Cherry, thank you. Let's wait for the others. Okay. Few more minutes. Okay, good. I mean to say, sir, pag manual computation, Cherry, could you share your question to everyone, please? Okay. No, actually, you don't need to compute for log 0. Pinakita ko lang to illustrate. Okay. So we could have dispensed with computing for log 0 because we know it will be 1. Okay. So if you don't compute this, it doesn't matter. What we're really interested in are log 1, 2, 3, etc., not log 0. Okay?
Sorry sir, ang meaning ko po is, yung pag halimbawa po hinahanap po yung log 1, yung magiging basis po is yung log 0, right? Then yung log, kung ano po yung hinahanap na correlation. Tama po ba?
It's not log 0, it's the original time series.
Apa, yun po.
So ito, correlation with this one, no? Ito, correlation with log 2. The original time series, correlation with log 3. The original time series, correlation with log 4, etc. You're getting the correlation with the original time series. And ito kasi mga to, log ng ano to eh. These are logs of your time series, original time series. Di ba? Cherry, did that answer your question?
Yes po. Thank you po.
Okay, sige. All right. So sige, let's now go to PACF kasi mas madugo klase PACF. So I'll put here PACF. Okay. So what's PACF, class? PACF is the correlation between your your log, okay, this one, and okay, the subtracting the intermediate effect of your intervening logs, the effect of your intervening logs to your time series. So let's explain that. So for log 1, diba, you have y sub t and log 1. There is no intervening lag between y sub t and y sub t minus 1. Okay? Di ba wala namang y sub t na 0.5? Wala. So wala tayong ima-minus dito. So the partial autocorrelation between with lag 1 is just the correlation. So this will just be the same as is equal to correl ng original time series natin, control shift down arrow, control backspace, comma, and your lag 1. Pareho lang siya ng autocorrelation. There. Okay? You'll also get negative 0.659, etc. Okay? By the way, class, I hope you compare this with the autocorrelation that we got. No? And there will be a little discrepancy due to rounding off, but it's practically the same. All right, we now go to lag 2. Yung lag 2 class, the partial autocorrelation of lag 2 is the correlation between your lag 2 minus class yung intermediate effect ni lag 1 kay original time series. So ima-minus natin, ano ba yung impact ni lag 1 kay original time series? So we will have to subtract that. But how do you get the impact of lag 1 kay y sub t? You do regression. I-regress natin class si y sub t kay y sub t minus 1. So after we regress y sub t on y sub t minus 1, we're able to see, class, ano yung impact ni y sub t minus 1 on y sub t. And then after that, we get the residuals. Okay? So kukunin natin yung residuals, yun ang ima-minus natin dito. Okay, so let me illustrate that. Paki-answer nga class, paki-chat. Who among you are familiar with using regression in Excel? Are you familiar with using regression, computing for multiple linear regression, generating the residuals using Excel? Paki-chat naman please, yes or no? Okay, thank you. How about the others, please? Okay, thank you. All right, good, because this is an opportunity to learn for us. Okay, good. Sige. So let's do that, class. Okay. First, go to your data tab, class. Okay, thank you. Go to your data tab, and please, I need you to chat yes or no if you can see in the tab, and then this is your scrolls, okay? If you have analysis here and then data analysis. Paki-check nga kung yes or no, please. I'd like to know if you have that under data and then analysis, data analysis. Yes or no, please. Go to the data tab and then see if you have here your analysis ribbon. Okay. Tapos analysis, tapos may data analysis kayo. Yes or no, please. Okay, yes. Meron. Okay, good. No. Okay, may no. Okay. No. Analysis tools. Okay. How about the others? So dapat may data analysis kayo. Okay, here. You should have this. Okay, good. For those of you who have, then that's good. For those of you who don't have, we will install this first here. Be sure you have it. So please follow along with me. So for those of you who don't have data analysis in your scroll bar here. Okay, so let's go to File. Please go to File. And then at the bottom side here, you have options. Options class, and then go to add-ins here. add-ins. And then here below, you have manage Excel add-ins. Then you have go here, go please. And then your analysis toolpack is not clicked. So check that and then okay. And once you go through that process, go to data, and then you should have already your data analysis. Okay. Who was the one who said no a while ago? I think Kyrene. Kyrene ba? Who was that? Were you able to install it?
Yes po, sir.
Okay na?
I was able na po. Yes
Okay,
po.
good. Thank you.
Thank you.
Thank you. Okay. All right. So this is a pretty powerful tool pack in Excel. Okay, so what are we going to do? Let's begin first with the end in mind. We would like to get the correlation between this log2 data and the residuals of the regression that's generated from this one. Okay, so that's actually very easy in Excel. Okay, so let's put here PACF 2. So this is your partial autocorrelation log2. We're going to put here the results of your regression. So this is how we go about it. Okay, you go to data analysis. Okay, I hope you have written this one, PACF2. Data analysis. And then, so there are several statistical tools here. ANOVA, okay, t-test. Okay, you have your regression. This is what we're going to use. Regression, and then click OK. Then this dialog box will appear. Okay, let me close this. Okay. Oops. Okay. So first is Y. Y is your dependent variable. Okay, so wait, hindi ko makita yung... Yeah, let me first... Okay, hindi ko makita itong una. No? All right, so data analysis, regression, okay. What will be my Y range? My Y range will be my dependent variable. And that's your Y sub t. That's original. Why am I clicking this? Because my predictor is Y sub t minus 1. We're getting the lag, we're getting PACF2, lag 2. So I need to get the effect of lag 1 on the original data. Okay, so A3, control shift down arrow. Okay. So that's until 2516. Control backspace to go back there. And then comma. There. You can see it's comma. I'm sorry. We go below here. Our X range will be our predictor, which is Y sub t minus 1. Again, start with this one. Control shift down arrow. Control backspace. So you can see now that they're level. They're of the same length. 3 up to 2516. And then what we highlighted does not have any labels. So we will not click this. Okay. And we want the output range to be here. We want it to be below here. Let's put it here. L3. Okay. So our output range will be on L3. And then here, class, you have to click residuals. Because we want that the residuals will be generated because we're going to regress that. We're going to get the correlation between the residuals and your log2. Okay, so let's run this. Then it will generate your regression model here. Okay. Okay, so this is your regression model. This is the effect. This is the effect of log1 on your original data. And the residuals is this one. So we're going to need this. So let's now compute for the partial autocorrelation. It will still be correlation between log2. Okay, of course, it's log2 here. This is your log2, right? Control shift down arrow, control backspace, comma. Okay. And now your correlation is between that and your residual here. Now your residuals was based on this regression class, right? It was based on this regression. So it has one more residual as compared to our lag 2. So I'm going to highlight the residuals, but I won't include the first one. Just here, then control shift down arrow, control backspace. Okay? And then shift close parenthesis. So take note now, correlation between this one, 4 up to 2516, and then N28 up to 2540. If you subtract the difference, it's equal. Okay, so good tayo. Had we highlighted N27, this would have generated a wrong answer. So control enter class. So the correlation, partial autocorrelation at lag 2 is negative 0.01079 something. Could you kindly check, please, what's the partial autocorrelation in lag 2 in R class? Is it the same as this one? Please kindly check. If the partial autocorrelation we generated in R is the same as negative 0.01079. Hello, class. Hello. Quick feedback, please, because we have a lot to cover. Is this the same as the partial autocorrelation lag 2 class that we generated in R? Kindly check your R, please. Maybe not exactly the same, but really close because of rounding off errors there. Yeah, my counting difference, but it's maybe to the four decimal places. Okay, there's a really very small difference. Okay, practically the same, yes, correct. Okay, all right. So yeah, we were able to kasi class yung itong mga returns na nakuha natin, truncated na to. Okay? In the real R file, hindi siya ganito, no? Mahaba ang decimal place yan. That's why you need really not get the exact partial autocorrelation. Okay, so I hope you got it, class. So let's just use the last one here. So what will be the lag 3 class, the partial autocorrelation? It will be the correlation between your lag 3 and, okay, the intervening, minus the intervening. The intervening is, okay, this one. You're now going to regress the effect of lag 1 and lag 2 on your original. So we'll do regression again with this as your dependent variable, your y, and this is your independent variable, your x. Okay, so dalawa na yung tatanggalin natin effect, yung yt minus 1 and yt minus 2. So let's do that. Once again, go to data analysis. Okay, let me write here first. Okay, dito nadodoble yung upper lower. Tanggalin ko na to. No need for that. Delete. Okay, I'm going to copy this, Control C, and then put it here, Control V. Okay, this is PACF 3. And we're going to generate here the regression output plus the residuals. We need the residuals. Okay, so once again, data analysis, regression, okay. Then what will be our Y range? Our Y range class will be from here. We will regress it on these two variables. Control Shift down arrow, Control backspace, and our X input will be these two class. Okay. 4 up to Control Shift down arrow, Control backspace. So same same number of rows, 4 to 2516, 4 to 2516. Same thing. Let's put the output range here in this side. So that's your here. T3. I'm going to put it there. And then once again, the residual should be printed also. Okay, so let's run this. And you can now see that the regression has two parameters. So this is the effect. of y sub t minus 1, this is the effect of y sub t minus 2. Okay, and if you subtract that, you'll get this, the residuals. Okay, so we're getting now the correlation between the residuals. Okay, so this is equal to correlation, once again, of log 3, control shift down arrow, control backspace, comma, and notice the regression has one more observation. So we need to remove from the residuals the first one. Okay. Control shift down arrow, control backspace. And you notice 516 minus 5, that's 511. This is also N28. Okay. N28 to N2540. Okay. N28. Yeah. Okay, I'm not including this one. Five, 2511. Pero ito, parang may mali. Kasi parang hindi magkapareho yung ano nila. Check. Okay. Control Enter. Say NA class. So something's wrong. Hindi magkapareho yung ano. Okay, wait. And let me check our regression again. So this one is from 4 to 516. And this one is B4, C4 to 516. That's correct. Output range T3, residuals. Okay, okay. Okay, overwrite. This is N28. Sa V. Ay, sorry, o nga pala, ano? My bad class, sorry. Thank you. I was using this one, this was the first model class. Okay, my apologies, yeah, very bad. Yeah, sorry, that's why you see their error, because it's not the same, okay? Okay, it's not the same. Yeah, thank you, Joyce, thank you, James. Okay, so, okay, I got, mali yung kinukuha kong value, no? This should not be N class. Okay? This should be here. Yung residual natin sa piece ACF3. Here. From here, and then control shift down arrow, control backspace. There you go. So check mo 29 to 540 minus 29, that's 511. So, ito din 511. So, okay na to. Alright? So, control enter. There you go. Sige nga, class, pakicheck kung pareho yung partial autocorrelation natin. Dito sa log 3 class. Okay, it will be pretty much the same, practically equal. There will be a little difference, but that will be negligible. All right, so that's how you compute class for the partial autocorrelation. And again, why do we need this class? Because we need this to identify which will be the model class. Will it be an AR model? Will it be an MA model? So be sure, class, in the exams kasi I'll be asking, kunyari magbibigay ako ng ACF and PACF. What could be the most probable model there? Okay? So be sure to know, pag significant lags lang sa ACF, and then geometric slow decay, geometric exponential decay, mabilis na decay dito sa PACF, then that's an MA process. For the reverse class, significant spike dito sa PACF, cut kagad class, tapos dito, geometrical or exponential, mabilis bumaba kay ACF, then that will be an AR process. So let's go back, class. We have, we're running out of time. Okay. So, good thing is that we can use Arima function in order for R to generate the model for us. Okay, using Arima class. Okay, so here Arima 1, model. See, the order is 100. So this one we did last time. There you go. Andito yung parameters natin, di ba? Okay, and if you use LaTeX class, it should look like this. So this is the equation. Y sub t, and that's your y sub t is your Apple log returns. That's what we're modeling. Is equal to, this is your intercept plus negative. This is the coefficient of your lag 1. Diba ito? Plus AR1. Yan. Lag 1 siya. So which means you're modeling your y sub t based on its past values plus your epsilon sub t error term. You were supposed to submit to me, class, the assignment, but I decided against it. So anyway, so I hope you did it. So let's just compare outputs. For MA1 model, it should be this one, class. And your equation should look like this. Y sub t is equal to 0.009 plus negative 0.0675. The predictor now is your residual, lag 1 of your residual, epsilon t minus 1, and then plus your epsilon sub t. Okay? All right. So I hope this is clear, class. This is supposed to be a collected assignment. Okay, Arima 1-1 or Arma 1-1. Okay, if you do this, you have your AR component and then your MA component plus your intercept. Okay, so this is the equation. Y sub t, which is your Apple log returns, is equal to 0.009 plus 0.1749 times y sub t minus 1 plus negative 0.2421 times epsilon sub t minus 1. So your MA1 will always be multiplied to your epsilon, so epsilon t minus 1 plus a certain error term. And then moving forward, class, same thing here. Now, take note, this is Arma 201. And what will happen is usually if you try a higher order model, usually nagkakaroon kasi ng multicollinearity. So sometimes it might create this warning. Warning, not a number produced. But you have the AR1, AR2, MA1. Kasi Arma 2, 1, 2 di ba? 2 lags of AR and 1 lag of MA. So assuming that model is okay, let me first share with you this one. Lagay nyo na lang sa I need to share it twice because so this is just to explain the bakit nagka NANs. No? So you are aware that especially this happens when you have, sabi ko, higher order nga na ito 201 nga, medyo nagka-NNAs na siya. So this just shows that may possible na may multicollinearity or possible na model overfitting. So pag sinabing model overfitting, masyadong maano yung model natin. Masyadong complicated. Kasi baka kaya naman ng AR1 na or MA1, di ba? So bakit pa Arma 2-1? So when that happens, minsan nag-generate ng not a number, ibig sabihin nagkakaroon ng multicollinearity or model fitting. Okay? In our case, the presence of NAN suggests that there may be issues with multicollinearity and overfitting or insufficient data. Sa insufficient data naman, hindi naman kasi 2,000 plus yung data natin. Okay? So in our case, it might be multicollinearity or overfitting, which might lead us to just use a more simple model. Okay, so this is the equation. Ito yung AR1 component, ito yung AR2 component, ito yung MA component. Your MA class, as we said, will always will always be multiplied to the residual, lag of the residual. While the AR will always be autoregressive, will be the multiplied to the coefficient of the lag of your time series itself. Okay? All right. Then, this one is 102. Okay? Hindi ko na Okay, 102. Ganun din, ano? But meron din tayo, may mga not a number dito, which indicates that hindi pa pwede itong model na yan. Ito naman, 111. So what's this one, class? The one here stands for differencing. So ibig sabihin, i-difference pa natin, class. Okay, so pag dinifference natin, are we still working on the same time series? Apple log returns pa rin ba yun? The answer is no. Kasi dinifference na natin siya. So, this one, if you run this class, you notice that the result is, look, Arima 111. First order ng AR, one order ng MA, and then you're working on a difference series. So here, okay, pakita ko lang to, class, no? All right. Notice now that your equation is not y sub t anymore. It is now delta y sub t or d difference y sub t. Ang ginagamit natin d, di ba? Pwede rin gamitin delta. So, we cannot compare anymore yung y sub t model at saka delta y sub t. Kasi we're now modeling a different time series na. Magkaiba na siya. Okay? So the equation here is phi1 delta y sub t minus 1, and your phi1 is, di ba ito? Negative 6.56. Your MA naman is negative 1. Negative 1 to. Okay? Hindi ko pala nasulat yung ano. Okay, so you have higher models here, 211. Okay? So I hope you tried that, class. Okay? Meron tayong AR1, AR2, and MA. But again, ang minomodel natin dito, class, is a different time series. So if you say, ano mas maganda, class? Arima 11 or Arima 111? The answer is, you can't compare. They're incomparable kasi iba na yung time series na minomodel natin pag Arima 111. Okay? All right. All right. So let's go here. We have a short time here. Okay, I want you, class, to copy this. Kasi, paano yan? Iisa-isahin ba natin yan? Are we going to do it manually, one by one? Buti na lang merong auto.arima function. Okay, ito yung pinaka-simple, no? Auto.arima coming from the forecast package. So I want you to write this, class, itong function na to, so that we can automatically select the best Arima model. So I'm writing your best model, and then using the forecast package, there's this function auto.arima, and then Apple log returns, and then print the best model. Okay, so if you run this, class, run. Okay, before we discuss, I'll give you a few seconds to write the code. Once you're done, class, kindly please chat yes, please. Okay, I hope you can do that faster. We have okay, done, class, done. Okay, only one is done, class. Okay, all right. I hope you did this, class. And if I run this, class, you can see that it tells us that the best model is Arima 100. Okay, AR1, and the mean. So this is the first model that we did, class. And it based it on AIC, ACF information criteria. Okay, please copy that, class, copy that. And let's expand, copy that code, and then let's create another one, best model 1. This time we're going to add this, class. Trace is equal to true. Okay, we're going to add this trace is equal to true. And let's see. What will happen is that this will list down all the models that it will be looking in at class. And then let's run this. Take a look at this class. It looked at several several models class. And then first, it made a approximate computation. Kasi dito yung Arima 100 natin, negative 130.94. Ang Arima 001, negative 130.93. So among all of this class, Arima 1001 is the best class kasi siya yung pinakamaliit na kaike. Remember class, negative to, no? So the smallest will be the highest in absolute value. Okay? So if you take a look at this one, and sabi niya, the best model is Arima 100. Okay? Sabi niya dito, now refitting the best model without approximation. Kasi nung una, in-approximate lang niya. And then, inulit niya yung model. Notice dito, ang Arima 100 is 130.94. Without approximations, it became 130.93. Medyo lumaki ng konti, no? Pero mas malaki na yung class, mas maliit yung Arima 001. So this is interesting kasi dito, parang possibly baka hindi si Arima 100, baka si Arima 001 kasi in-approximate lang niya dito eh. And this one class, although my trace is equal to true, medyo may limitations yan. Okay? So I'm going to share with you this one class. Okay. Mahaba to kaya share ko na lang yung code na to. Control C. Okay. Paki-copy to class. Control V. Okay. And malapit na yung time. So let's see class, no? Best model to auto.arima din, Apple log returns. Pero may tayo, may mga conditions. Seasonal is equal to false, stepwise is equal to false, approximation is equal to false. Ang sabi natin, huwag siya mag-approximate, no? And trace is equal to true. Kasi kanina, nung sa trace is equal to true, nag-approximate siya. Ngayon, sinasabi natin, huwag siya mag-approximate. And then let's run this. Okay, you notice now that it has more. It generated more. Okay, mas marami siyang generate na models. No? Okay? Mas marami siyang generate na models. Tapos wala na tong approximation. So kung titingnan natin to class, Arima 001 with zero mean is, ibig sabihin na class ng zero mean, wala itong mean na to. Okay, zero yan. Okay? Ito naman, Arima 001 with non-zero mean is 1393.3. No? So mas maganda yung with non-zero mean kasi mas mababa yung niya, yung AIC. No? And if we compare this with AR 1, 13088 with non-zero mean 1393.08 compared to yung Arima with non-zero mean 93.3, yung AR 93.08. So mas mababa class. Si MA 001. Mas mababa siya. And true enough, ang sabi niya dito, the best model is this one. MA 001. So that one. So mas maganda yung code dito class kasi we do not allow approximation dito. Kasi yung sa una, yung trace is equal to true lang, nag-approximate siya. Okay? Kaya that could have led to some of the discrepancies. So dito, tapos hanggang Arima 5 nga pinasok niya, di ba? And then it turns out that mas maganda talaga yung Arima, yung MA1. And if you go back class to the plot. Okay? Sorry, it's almost time class. I'll just end here. Yung plot natin dito class. Diba ito? Significant spike siya dito. Significant spike. Okay? Diba? And what was the value of that? Tapos dito, may mga significant spikes, but I said, diba, itong mga to minsan hindi na sinasama sa model because of multicollinearity. So, significant spike lang sa ACF. Then that's a candidate for MA. Tapos sa PACF mukhang geometric decay. Okay? So in fact, we took a look class at the, di ba ito, negative 0.0659. This is the correlation. Take a look at our model. Ano yung model natin, di ba? Ito, class. Our model is negative 0.675. So practically very close to the correlation. Yeah. So that's our model class based on the auto.arima function. Okay, so final model class, ito. Here. Sorry, below. So your y sub t is equal to negative 0.009 plus negative 0.0675 times epsilon t minus 1 plus your error term epsilon sub t. So that's your final model for this Apple. Anong susunod? I-check natin diagnostics. Kukunin natin yung residuals ng model natin. Tapos titingnan natin, dapat class, pag prinat natin yung ACF and PACF na residuals, dapat white noise na siya. Dapat wala ng significant lags. Kung may significant lags pa, ibig sabihin, may problema yung model natin. May mga hindi nakaka-capture. Okay? So,